All right. So in the previous class, we were studying about support vector machines, and I have explained the concepts related to it. That SVM is used for both regression and classification. SVM is one of the strong machine learning algorithm which is having a good capability, and it can be compared with deep learning neural network also. Okay, and the goal of support vector machine is to find optimal hyperplane. Okay, optimal hyperplane. That means we have to divide data points, and these data points are divided by hyperplane. Hyperplane is a decision boundary also, and the dimension of hyperplane is one less than the features. If you are having n features, so the dimension of hyperplane will be n minus 1. Okay, that means if you are having two features, two classes, okay, that means I'm talking about the number of classes, features, the number of classes. Okay, so if you are having 2D data, 2D representation, in which this is how you can represent the classes. For example, this is F1, this is F2, these are the two features, and this is class A and this is class B, so you can separate it with a line. Okay, so your data, if it is 2D, then I can separate it with the help of a line. If it is 3D, then I can divide it with a plane. So plane is 2D. Okay. So if you are having a 2D data, we can divide it by a line. Then 3D, we can divide it by hyper a plane like 2D. If you are having 4D, then we can divide it by 3D. Okay, and so on. So, if your data is divided by a line, then it is said to be linearly separable. Okay, if it is divided by a line, then it is said to be a linearly separable. We are having two classes here, class A and class B. Okay, so such kind of data is said to be linearly separable. It's an easy case. It's not mandatory that you can only divide the data by a line. In my previous classes, I have also shown you that there is intermixing in the data points. So obviously we do have different kernels, different technique to separate the data. That means we do project such data points on higher dimension, then we can classify or separate it. Okay, so The concept of hyperplane is very much important here. We need to find the optimal hyperplane, and the entire maths of SVM is based upon optimal hyperplane only. Okay, so you do make SVM, the working of SVM in this way, like, okay, this is your hyperplane, this is your class A boundary, this is your class B boundary, this is A, this is B. Those points which are present on the class boundary, they are support vectors. So these are the support vectors for class A, these are the support vectors for class B. Rest points are also present here. Okay, so support vectors do provide a support for us to build the optimal hyperplane. We want the data points of class A and class B should have to be at a maximum distance. We want this distance to be max. This is called as margin. So we want this distance to be max so that I can clearly separate. Okay, I can clearly separate the classes A and B. Okay, fine. So here you are having 2D data, and to separate the classes, I am in a requirement of a line which I am calling it as linearly separable. And this is what I want to be maximum. Margin should have to be maximum. So we can clearly separate the classes. Okay, so we have also learned the concepts in the previous class related to soft margin, hard margin. We also checked the kernels in SVM. Okay, so all things were discussed in the previous classes, and in today's class, I need to talk about the maths for the SVM. Okay, so obviously we will be picking up linearly separable data only. That is the basic case of SVM, which can be extended. Okay, to work with SVM maths, to perform the optimization, the concept of vectors is very much important here. Okay, because the name itself says, in case of SVM, support vector machine. So if I need to make vectors, again I am making this diagram. You can see these data points, these are support vectors. I can make them as a vectors like this. Okay, and these are also the support vectors. You can make like this. So concept of vector is very much important. Okay, now if I do talk about a vector, it is written as x vector, for example, that is equal to x1 I cap plus x2 j cap. You very well know about the vectors. Okay, so like this. Here is a point. I can mark like in this way. This is x1, this is x2. This is a point whose coordinate is x1, x2, and this is how you can make a vector. Okay, so let's call it as x vector, vector which is having magnitude and direction both. So I can write a vector in this way: x1 I cap and x2 j cap. I cap and j cap are the unit vectors. Okay. in direction of x and y. Okay, so that's what it represents. Okay, now if I ask what is the length of a vector, so length of a vector, that means I am talking about the magnitude of x vector. That's what I am asking. So magnitude you very well know, it is written as like this, and we can calculate the magnitude like this: x1 square plus x2 square. This is the magnitude of a vector. That is the length of a vector. Okay, and we have also studied in maths that length of a vector, okay, you have mentioned, that's what it's called. Also, unit vector, where we say vector divided by its magnitude or length, then it is said to be a unit vector. So we are having x vector as x1 I cap plus x2 j cap upon the length. I can rewrite it as x1 I cap plus x2 j cap. I can write like x1 square plus x2 square. Since we are dealing with an algorithm which is having a vector word in it, so right now we are just trying to understand what are the basics of vectors. Okay, so I can just split it like x1 upon under root of x1 square plus x2 square I cap plus x2 upon under root of x1 square plus x2 square j cap. That's what I can do. Or you can write it like this: x1 upon mod of x I cap x2 upon mod of x j cap. That means the length of the vectors, and we are having the individual values. Okay, so here these two values which you are getting, these are the unit vectors in direction of x and y, or I would say the unit vectors in the direction of, here you can say, I and j. These are the components. Okay, I can again make this vectors like this. This is my x vector. Here is my point, that is x1, x2. Let us suppose it is making an angle theta. Here, this is making an angle theta with the x-axis, and let us suppose this is making an angle alpha with y-axis. Okay, so I can write w is equal to x1 upon magnitude of x, x2 upon magnitude of x. This shows the direction. This shows the direction of vector x. Obviously, this is my x component. This is my y component. Okay, it's a unit vector. Okay, so it shows the direction, and I can write it like this also: w is equal to cos theta cos alpha. You can see what is cos. Cos is base upon hypotenuse, so you can find it easily, like, okay, this is theta angle na, so x1, so base upon hypotenuse, so this is x1 upon mod of x, and this is again base upon hypotenuse. Okay, so x2 upon mod of x. Okay, fine. Then the next thing comes under the vectors. Let me share my entire screen. Is the angle between the two vectors. Okay, so now see the angle between two vectors. This is my x vector and this is my y vector. Okay, this is x and y. This is angle theta. Okay, this is my x axis, this is my y axis. So, in vectors, what we have learned, if there's an angle theta between them, therefore x dot y, that is the dot product of the two vectors, it is given as mod of x mod of y cos theta, where theta is the angle between the two vectors. We have seen this formula. So far, what we did in the previous discussion here, I made a vector represented by this. I found the magnitude of the vector, which is also called as the length of a vector. Okay. Then I found the unit vector, that means the vector divided by its magnitude. So I took these two components, which shows the direction of the vector, and I can represent it with the cos theta and cos alpha according to the diagram here which I have made. Now I am taking two vectors x and y. There is an angle theta between them, and according to the formula which you very well know, the dot product of the two vectors, it is given as xy cos theta. Okay, so I need to do some maths here. What kind of maths I'm looking forward for? Let's see. Let us suppose the entire angle is beta. This angle is alpha. So theta is equal to beta minus alpha. Okay. One more thing. Let me drop the perpendiculars. So this much length is x1, this much length is x2, this much length is y1, and this much length is y2. Okay, so theta is equal to beta minus alpha. I need to find the value of cos theta, so let me put cos on both the sides. Cos theta is equal to cos of beta minus alpha. Cos theta is equal to cos a minus b. You know about trigonometry. The formula of a minus b, cos a minus b, is cos beta cos alpha plus sine beta sine alpha. Cos a cos b plus sine a sine b. That is the formula of trigonometry. Okay, so I think we can calculate what is cos beta, cos alpha, sine beta, sine alpha. Just check the diagram. Cos beta, this is beta. Cos beta is based upon hypotenuse, so that will be like cos beta is equal to x1 upon magnitude of x cos alpha, this is alpha na, so that will be again y1 upon magnitude of y, that is cos alpha. Sin beta is equal to, you can check perpendicular, so this is x2 upon hypotenuse, so that is x2 upon magnitude of x. Then sin alpha is equal to y2 upon magnitude of y. Okay, so these are the values. Now put in the equation here. Therefore, cos theta is equal to x1 upon mod of x dot y1 upon mod of y plus x2 upon mod of x dot y2 upon mod of y. Now that will be x1 y1 upon mod of x mod of y plus x2 y2 mod of x mod of y. The denominator is same. Therefore, it will be mod of x mod of y x1 y1 plus x2 y2. Okay, and that's equal to your cos theta. You can do one thing. Just take this mod of x mod of y here. So that will be mod of x mod of y cos theta is equal to x1 y1 plus x2 y2. Therefore, it is now your x dot y. So that is x1 y1 plus x2 y2. We have to remember this thing. The dot product, the dot product between the two vectors is the product of their terms which are in I and j directions. Obviously, dot product is a scalar quantity. Okay, so here you are getting a scalar quantity only. That means a number. Okay, fine. So this is what we achieved here, and I can write it like in a generalized way. That is x dot y is equal to summation I equal to 1 to n xi yi. That's what I can write. It's a generalized formula. Okay, fine. So what we have seen so far is the basics of vectors. Now, as I started with linearly separable, that means you require a line to divide a 2D data actually, 2D. For your 2D data, you require a line to cut it. That's what you are seeing linearly separable. Okay. And we do have hyperplane which perform this thing. So line is a hyperplane only here. Okay. So what is the equation of a line? You write the equation of a line is mx y equal to mx plus c. This is how you write the equation of a line. Now, if I am having a diagram like this, again I am making this is A, this is B. So, okay, this is a line or a hyperplane which is dividing two classes. This is F1, this is F2. Two features, two class divided by a line. The equation of line is y equal to mx plus c. Okay. Now, M is the slope, C is the intercept. Okay. Let me rewrite this equation. Let us suppose it is y equal to ax plus b. Okay, it doesn't matter. I can just write in any of the symbols. So any of the alphabet. So y equal to ax plus b. Okay. Let us suppose x equal to x1, y equal to x2, x1, x2. Okay, just think of a line, this line. We have already about a vector. Okay, we have already learned about a vector. There we are having x1 and x2 for a point. Coordinates. Okay. So just following the same concept of vectors, I am here saying that let us suppose x equal to x1, y equal to x2. Okay, this is your x comma y. So let me put this x1, x2 here. X2 is equal to a x1 plus b. That's what I can write. I can also write, let's take x2 here. So a x1 minus x2 plus b equal to 0. Okay, got it. So this equation is your equation of a hyperplane. But I need to further reorganize this equation. How can I do? A x1 plus minus 1 into x2 plus b equal to 0. Now we have studied something about what we have studied. We have studied that. Okay, just check it here. This one, x1 y1 plus x2 y2 is equal to x dot y. Can I perform this thing? A dot x1 plus minus 1 dot x2 plus b can be like written as it is. This is x1 y1 plus x2 y2, something like that, which we have studied above. So I can make these as a vectors. The vector w is having a and minus 1. Vector capital X is having x1 and x2. Just refer to the one which we have derived recently. So this is the dot product of w and x, two vectors, plus b equal to 0. So this is the equation of hyperplane. Okay, fine. Very much important. Okay, now the next thing is you got the equation of hyperplane. Okay, let me again make the diagram for the SVM. This is your hyperplane. Its equation just recently you have found, that is your wx plus b equal to 0. You are having two classes. Okay, right now we are just dealing with the linearly separable. Okay, you can say this is class A, this is class B. Okay, so in the previous lectures, so we have also studied that anything above the hyperplane is positive and below the hyperplane is negative. So this is the positive side above the hyperplane, and this is the negative side below the hyperplane. Therefore, if I'm doing classification linearly separable, it's binary classification. Let me have this is positive class and this is negative class. Okay, positive class and negative class. A and B can be represented as plus 1 and minus 1. Therefore, the equation of the that is inequality, an equation of inequality above the hyperplane can be written as, okay, can be written as, okay, fine, wx plus b greater than equal to plus 1, wx plus b less than equal to minus 1. Obviously, the equation between them is wx plus b equal to 0. That is hyperplane equation. Okay. So I can say above the hyperplane positive class. So anything which I'm going to put inside this equation that will come to the positive if it is having this class. So my class is plus 1 and minus 1. Okay, positive and negative. That's what the SVM says. The basics of SVM. You are having positive and negative class. Above the hyperplane, positive class. Below the hyperplane, negative class. So accordingly, I have put plus 1 and minus 1. Okay. So in the diagram, I can again just connect this line. Okay. So this region is represented by an inequality wx plus b greater than equal to plus 1. This region is having an inequality wx plus b less than equal to minus 1. And it's also like represented. You may see at different places. Okay, let us suppose this is h2. Let us suppose this is h1. So they are considered as class boundaries. Okay, so this is h2, this is h1. H1 is the class boundary of negative class, H2 is the class boundary of positive class. And they are being assigned these equations. Okay, so here it can be assigned as wx plus b greater than equal to plus 1, and here it is assigned as wx plus b less than equal to minus 1. Like this, they have been assigned. The only thing is, we are talking about the regions, positive region and the negative region, positive class and the negative class. Anything which is falling under these regions are like
Correct.
separated. Okay, got it.
Sir,
Yeah, please say, Abhishek.
So this is wx plus b has to be greater than 0 and less than 0, right?
No,
Plus
no.
1 and minus 1 represent distance of unit
See,
distance
no, no,
or
no, no. I think you might have seen somewhere greater than equal to zero. Yeah, that's okay. They did mention, but kindly focus upon what terminology I have used. I am using this terminology: positive class and a negative class. Okay, so positive class is this one. Okay, above one. In regards to that, I have mentioned greater than equal to plus 1. And then in regards to this negative class, I have mentioned wx plus b less than equal to minus 1. Okay, you are not wrong, Abhishek. You are not wrong. You are saying that, sir, you have already taken hyperplane wx plus b equal to 0. So anything above 0 is positive. Anything below is is negative. Okay. So in order to represent this positive and negative, I require something as in form of classes. So this is a way to show it in form of classes.
okay, sir.
Okay, and remember one thing, I already explained in the SVM previously that I need to find the optimal hyperplane, optimal this thing, optimal, and the class boundary should have to be like big margin, max margin. Margin should be max. That's what we want. The width should be more. So from here the class boundary starts. From here the class boundary starts. So I'm not saying that anything above here only. Okay, you can say here are the support vectors. Here are the support vectors. Okay, here are the support vectors. So assign them as okay, minus 1 and plus 1. Positive class and a negative class. Okay, and then here is the equation which we can write. Somewhere might be you have seen greater than equal to 0, less than 0. There also, if you do check properly, check the target, check the classifier. Obviously, they have mentioned this thing. Y minus 1 and the plus 1. Positive class and the negative class. Okay. So I have these equations wx plus b greater than equal to plus 1, wx plus b less than equal to minus 1, okay, where y is equal to plus 1, y equal to minus 1. I am having these two equations. I need to merge them. I need to merge these two equations. So merging, what I'm going to get here is y wx plus b minus 1 is greater than equal to 0, where y is equal to plus minus 1. Now the question is, sir, how you did that? It's very easy. You can test this equation. If I put plus 1 here, so 1 wx plus b minus 1 greater than equal to 0, that will be wx plus b minus 1 greater than equal to 0, wx plus b greater than equal to 1. This is my first equation. I got it. Okay, this is my first equation. I achieved. Okay, got it. Then, okay, you can put minus 1 now. So, minus 1 wx plus b minus 1 greater than equal to 0. Because of the minus sign, okay, if you take minus sign outside and you can write like this wx plus b plus 1 greater than equal to 0, with minus sign a sign reverses. inequality reverse. So what it will become now? It will become like this: wx plus b plus 1. It becomes like this, because if you remove the minus sign, inequality reverse, and then you can put it here: wx plus b less than equal to minus 1. This is your second equation. So by using the value of y plus 1 and minus 1, I can achieve this also and this also. So here is the combined format of the above two equations. I did combined these two. Okay, so I got the equation. Let me write it again: y wx plus b minus 1 greater than equal to 0. This is my equation for the hyperplanes. Okay, but these hyperplanes is subject to margin. Okay, because again, if you see, okay, I am saying that this is your hyperplane, this is your h2, this is your h1. We have combined the equations of h1 and h2, h2 h1, whatever you want to write, you can. This is the margin, and we are doing this maths, whatever we have learned so far, to find optimal hyperplane. An optimal hyperplane should have maximum margin. That means as much as far these two are, I will be having good separation of the data points. So I want maximum margin. That's the concept says for optimal hyperplane. Okay. So how to find what will be the value of margin? M. Let us suppose it is M. What I can do is, now see, again, I'm making a good diagram here. Let us suppose this is your hyperplane, this is your h1, this is your h2. Okay, this is h2, this is h1, this is origin. Okay, this distance will be the margin. Distance between the hyperplanes will be the margin. Now this distance can be calculated as, let us suppose this is the distance of hyperplane h2 from the origin. This is the distance of hyperplane h1 from the origin. So let us suppose this is d1 and this entire is d2. So margin will be equal to d2 minus d1. Okay, this width will be equal to d2 minus d1. Now, if you remember in 3D coordinate geometry, what we have studied in 11th standard or something like 11th or 12th, we have studied, if I need to find a perpendicular distance from origin, okay, over a line, let us suppose your line is ax plus by plus c equal to d, let us suppose. So if I need to find the distance x1, y1, the distance of this point from the line, we can put the value of these here, okay, in the equation. Okay, d, okay, no need for d. Ax plus by plus c is equal to 0, or whatever you can write again. So we have to put the values here. Okay. So a x1 plus b y1 plus c divided by under root of a square plus b square. This is the distance. This is the distance formula of a point over a line. If I drop a perpendicular, the distance formula. Here the point is origin, and the equation of h1 and h2 are equation of h1 is wx plus b less than equal to minus 1. Equation of h2 is wx plus b greater than equal to plus 1. Let me draw perpendicular over them. Okay, let me drop a perpendicular over them. So what I can do here is you can take that on this on that side and this also on that side. So it will be h1 like it will be 0 minus 1 minus of wx plus b. H2 will be like again 0 greater than equal to 1 minus wx plus b. And if I drop the perpendicular on h1, so I need to substitute the value of coordinates here in x and y. I don't have any y here. I just having x only. So that will be minus 1 minus of wx plus b like this, and I can put the value of x equal to 0. So minus 1 minus of w into 0 minus b divided by under root of only w ka square. So that will remains the w. You understood why I am saying under root of w ka square? Just check it here. The coefficient of x and y, their sum square is calculated here. So I don't have any y, I am just having only x. So w square ka root is w. So it will be like minus 1 minus b upon w. So this is the distance d1. So d1 is equal to minus 1 minus b upon w. Similarly, I can calculate d2. What is d2? d2 is, okay, I can find here, let me put the 0 and let me write it. So it is like 1 minus w into 0 plus b. So it will be 1 minus this is 0 minus b upon w, here also w. So this is d2, and margin is d2 minus d1. So you can write like this: 1 minus b upon w minus of let me take this minus sign here, so it will become plus. So it will be 1 plus b upon w. Let me take the LCM. In LCM I am having w 1 minus b plus 1 plus b to b cancel, I am getting 2 by w. So margin should be equal to 2 by w. Important. Did you understood this thing or not? Please tell me. Have you understood this thing? Yes, Mr. Abhay understood.
Yes, sir.
Okay, Abhishek also understood. Okay, so very important maths for SPM. So far, we have calculated the margin. We have to optimize the margin. So I will be having the rest of the maths, important maths, which is left to perform the optimization, and that optimization will be related to margin only. I need to increase this now. So my goal is to maximize 2 by w. Okay, how I should be doing this? So that I will be covering in the next lectures. Let me stop sharing.